Hello, hello. Welcome. It's another Tuesday, and that means that it's another show for All Around Azure. My name is Jason Hand. I'm really excited to be here again with you on what turns out to be our 55th episode of All Around Azure. And to celebrate that 55th episode, I'm going to bring back one of my very special guests that we've had on lots of times and will continue to have on because he is one of my favorite experts in this area within serverless. So without further ado, let's bring in my good pal, Brandon. How are you, Brandon?
Hey, Jason. Good to see you again, man. Thanks for having me back.
Yeah. Sorry, let me mute some things here. Yeah, it's so good to see you. We were just chatting right before we got started here that this will be our third time doing this,
That's right.
talking serverless. We are trying out some new tech, some new stuff. In fact, I should just say here very early on that we are now, if you're joining us over on Learn TV, we are now able to chat with you through Learn TV. So I'm not sure if that's going to be turned on exactly during, when that turns on, I guess, on Learn TV. But we should have chat. We'd love to interact with you over there. We'd also love to chat with you on the Twitch channel if you're joining us from there too. So hello, everybody, and welcome to another All Around Azure. So Brandon, why don't we, first of all, let's give us a little bit of background for those who have maybe just joined us today, have never seen you before. Give us a little bit of background about who you are and the kind of stuff that you usually work on.
Certainly. So, my name is Brandon Minnick. I am on the developer advocate team at Microsoft, and specifically, my expertise is in mobile. So, creating iOS apps, Android apps using C Sharp and Xamarin. And that's because I'm a little biased. Oh, actually, I'm wearing my Xamarin my Xamarin jacket today. I used to work at Xamarin. That's how I landed it. Ended up coming to Microsoft because we got acquired a couple years ago. But yeah, with mobile, well, every mobile app needs some sort of backend, and that's kind of how I grew into Azure because a mobile app is great, but where are you going to store data? How are you going to interact with other users? How are you going to do push notifications? All that stuff has to happen in the cloud. And when I started getting into all these cloud services in Azure, I really fell in love with serverless because, well, there's a couple reasons. One being just the cost. It's basically free, and I have a couple apps in the App Store that they're totally free apps. Actually, one of them's even open source. All the code's on GitHub. I don't make any money off these apps, but they still need a cloud backend. And because I have a $0 revenue stream, it's expensive to start spinning up APIs and stuff like that are running in the cloud 24/7. And what I found with functions, well, serverless Azure functions that we'll be playing around with today is they only run when you need them to run. So they're available 24/7, but they're not consuming CPU memory resources in the cloud 24/7. And it's that resource consumption that Azure charges us money for. And so with the couple mobile apps that I have, I use Azure functions that are totally serverless. They spin up resources when they need them. They go back down to zero resources when you don't. And my monthly serverless bill for a couple mobile apps, couple thousand monthly active users has never been above 10 cents. So 10 US pennies, less than $1 a month.
Yeah.
And that's really been the huge selling point for me. I mean, there's all these amazing features. We're gonna be talking about queue bindings, queue triggers today, and how we can leverage those for microservice architecture. And the frameworks around Azure Functions is really awesome. But for someone like me who makes mobile apps in their spare time, nights and weekends, just doing it for fun, it's really the cost that I love because, yeah, I can afford less than $1 a month. I'm happy to cover those cloud costs.
Yeah, the cost is one big benefit, but just not having that extra equipment to worry about. The hardware side of it is also just take some of that cognitive
Oh
part
gosh.
out of the equation. Just let me sit down and write some code and
That is,
move on.
yeah, that is huge. Like, cause yeah, back in the day, if I wanted to do this 10 years ago, that would have involved me spinning up a virtual machine in Azure. And then, like you said, well, now that the virtual machine exists, it's basically my server in the cloud. So that means I have to install Windows updates, I have to do security patches, I have to set up all the routing for my web hosting with IIS or Kestrel or whatever we're using. I have to make sure that it stays online. So I have to do that, what's that called? Like disaster failure stuff. So like if virtual machine goes down, does it automatically reboot itself? And yeah, with serverless, you don't have to worry about any of that. I just write code. I right click publish in Visual Studio. So I just right click on my code and say, publish this to Azure. And then it just runs in the cloud. And
it's so
trusting, basically offloading to the experts at Azure, at Microsoft that know more about security than I do, that know how to install that stuff, keep the patches up to date, make sure there's no like denial of service attacks going on, that my APIs are going to be safe, that they're going to be up to date. And as a developer, I just have to write the code. I don't have to be an infrastructure guy.
Exactly.
So,
and then for me, like I come from the infrastructure side, and so like getting to know a lot of this stuff has really rewired my thinking about stuff. I come from the world where, I remember going and buying all the servers and racking them and stuff and like named them after, like spaceships and different things. And I'm so glad I don't have to do that anymore. And one of the big reasons is I like to just jump in head first and get busy working on an idea. And if I don't have to like configure a lot of stuff before I can actually start creating a thing and get, making some progress on my little, call it proof of concept, that's going to be the best scenario for me. Because otherwise I'll lose steam and I'll lose interest. If I like run into a problem or a bottleneck trying to set up an environment, trying to get like something perfect before I can even really start the work I wanted to do, I will lose interest and move on to something else very quickly.
Yeah.
Real quick, real quick. I want to say hello and thank you for joining us. We have a ton of new people that joined us from the Visual Studio Twitch channel. So thank you everyone who just came over and rated us from that conversation. Welcome. This is All Around Azure. This is Brandon Minnick. My name is Jason Hand. And today we're going to be talking about serverless. Essentially, it's part 3. We've had Brandon on now. This will be the 3rd time. And we're always talking about serverless. We've talked about different ways of triggering servers, all kinds of really cool stuff. So really great to have you. If you have questions about serverless, today we're going to be doing mostly .NET stuff, I believe, but serverless in general. Ask us any questions you have, both in Twitch as well as over on Learn TV if you're following us over there. And we also might, once we get into the demo portion of today, we might try to get some polls going and try to test out some of the functionality within our new chat system over on Learn TV. So hopefully you'll join us over there. Should be good. So thank you for everybody that's been joining. There's a couple of people that come back consistently through a lot of our shows over at Twitch. So Surly Dev and everybody else, it's good to see you. Thanks for tuning in. Yeah. Okay. So Brandon, what type of stuff? We've done a little bit of a recap of what we've already done and what kind of stuff that we're going to move it into. Remind me what I said we did, talked about triggers and stuff, but remind me some of the things that we already talked about that people today would at least need to know about before we get started moving on into queues.
Yeah. And so triggers is the perfect place to start when we're talking about serverless, because like we mentioned earlier, serverless functions, they don't run when they don't need to run. So they're always listening, they're always ready, but something has to trigger the function to essentially wake up and run. And so, when we did part 1 a couple months ago, we talked about HTTP triggers that for all intents and purposes that's an API. So like a GET request, a POST request, that would be the trigger that wakes up the function, runs your code, and then when the function's done running, spins back down all the resources back to 0, so you don't have to pay for them. And on the last episode, part 2, we talked about storage triggers, or blob storage triggers to be precise. And blob storage is essentially just like a folder in the cloud. I like to think of it as the same way of like, sometimes I'll create a folder on my desktop that says like vacation photos. Well, back when I used to go on vacations, back before we had a pandemic, I would just put all my vacation photos in that folder. And that's essentially what blob storage is. Blob storage is just a folder in the cloud where you can put anything. So if you wanted to put your vacation photos in it, you could. But any sort of just unstructured data, text files, could be JSON files, whatever. And blob triggers are cool because we use these a lot in mobile. So like if you say upload a picture to Instagram, Instagram stores that in, we'll say their version of blob storage, that actual photo. But as soon as they do, they take your picture and create different resolutions. So if you ever feeling bored, go to the Instagram website, right click and say view source. And when you find the source for that image, you'll see all sorts of different options. Like I think they have for different resolutions, like 720, 1080, blah, blah, blah. And so they do that so the photo looks really good on the different device sizes, different screen sizes, because what's the point of Instagram if the photo doesn't look really good? Mm-hmm. And so what we can do in Azure Functions to essentially do the same thing is use a blob trigger. So anytime a user adds a photo to this folder in the cloud to blob storage, that could be the trigger that wakes your Azure function to, in this case, process the photo, create different resolutions, create a thumbnail. And that was what we talked about at the last show. So on this show, we're going to talk about queues, because when it comes to these serverless functions, really what we're talking about is microservices. So Azure Functions actually have a rule in place. I always forget the time limit. I think it's 10 minutes, that if the function is running for longer than the time limit, and let's assume it's 10 minutes, either 10, 15, 5 minutes, set amount of time. If it's running longer than that, it just stops. Once you hit that time limit, the Azure function goes, nope, this is not what I'm meant to do. If you wanted a server that runs 24/7, go run a server 24/7. I'm a serverless serverless microservice. Yeah, I guess that works. And so what I like to do is I can chain functions together using queues. So for example, I could have, if we stay with that Instagram example, I could have a blob trigger kick off a series of other functions, almost like it's fanning out. So like the blob trigger has the photo from blob storage, and then it can put it on a queue, and that queue could be create thumbnail queue. And then I have another Azure function that is always listening to one queue, that specific create thumbnail queue. And anytime it sees anything on that queue, it'll pick it up off the queue and then run, process, do whatever you want. So that's a queue trigger. We're using queues to wake up our functions.
Yep.
And what the blob trigger did was it output to the queue. So that's a queue output. And yeah, that's pretty much what we'll be focusing on today, is how these queue triggers, queue outputs work, specifically in C# and .NET, and also how we can just chain these together so we have these microservices in the cloud that can just trigger off each other. And you don't have to worry about, well, I need to do all these steps, and all these steps are going to take 20 minutes. Well, break up those steps into microservices, chain them together with queues, and then you're good to go, and everything can still be serverless.
This sounds like my weekend, actually, when I was trying to work on some stuff. I just want I want this to do its own thing and this to do its own thing, and they both do their things very well, and we can just pass information back and forth using probably some JSON. And if there's a problem, it's easier to track down what the thing is. So all good points. And something else some of our viewers have been pointing out in the chat is there's a a few other big components. You're kind of hinting towards like durable functions and maybe the need for something that is a little longer standing, longer running thing, right? Longer running function, longer running application, whatever it is.
So kind of, the differentiation between needing, or the reason you would need a durable function is you need to know when a specific function completed. And what we're going to be looking at today is, it doesn't have that requirement. It's almost like set it and forget it, right? Like we're going to have that first trigger, and then that's going to output to a queue. But that first function that triggered doesn't really care what goes on after that. Like, it doesn't have to wait for it to finish. It doesn't need to know when it's done. It doesn't need to wake back up to do anything. But if it did need to know, hey, my buddy, the other function is now done, then I could run this next task, then that's where we'd get back into, or I wouldn't say back into, that's where we get into durable functions. Like, you almost have this orchestrator function that says, all right, you go, and then you go at the same time. And then when you're done, we can do that over there. And we don't need to wait for this one, but when he's done, we can do this over there. And so it's kind of like this, this maestro.
Yeah. Orchestrator is a great word for it.
Yeah.
Yeah. So I think that the durable functions is one conversation that comes up, for sure within serverless. And then another one, as one of our people watching the stream also pointed out, is the cold starts. Sometimes that's a little bit of a, it's a concern, a real concern, especially for applications that, people that are really being relied on something and do need that faster response time. What's your thoughts on cold starts, and especially, has that really been a huge problem for you, or what's your feelings on that?
Cold starts, obviously a great point, because the resources aren't being consumed in Azure. So yeah, if we have an HTTP trigger, if we have that get API that is in serverless Azure function, when, in my case, my mobile app hits that API, the first thing Azure does is has to go, let me allocate some CPU memory resources, spin up the code, get it running. And yeah, that takes about a second. And what I've done as a mobile app developer is just essentially some tricks to almost make it feel like everything's happening more quickly. So for example, when my app launches, shameless plug, Git Trends, GitTrends, is the open source app that's also available in the iOS and Android app stores. You can go to gittrends.com today. And when that app launches, you'll see the splash screen has some animation. So it shows the logo on the splash screen, and then it kind of animates it. So the logo jumps a little bit. I have some text that scrolls to the bottom that says something about like loading data, and then like the animation will jump a little bit and new text will slide across the bottom. So you're essentially distracting the user so that it doesn't feel like it's taking forever. Like, if we
let's say entertaining, let's say we're entertaining the user.
We are entertaining the user,
or informing. And a lot of times too, is that you're kind of loading in some information for them to consume, maybe read, while your app is getting ready behind the scenes.
Yeah. So there's basically, there's ways to work around the cold start. But what's really cool is what we're talking about today with these queues. These queues are usually handled as background tasks. So like, does the user need to know that their new photo is being processed and we're creating thumbnail images and different resolution images so that when it appears on, so that like when my photo appears on Jason's timeline, it's perfect to his screen. Like, the user doesn't need to know that. The user doesn't need to know when the photo's going to be published to Jason's timeline, for example. And so what's cool with these queues, yeah, there's still going to be cold starts there. There's like, unless you want to pay more for Azure Functions, which, as somebody who's making $0 off his mobile app, I don't. I could choose to pay more. There's paid tiers of Azure Functions that'll get rid of cold starts, so it's not even a problem. But yeah, these queues, I think of them more like these are microservices running in the background that they're not going to like the user's not waiting on a response from these. Another thing I'll use queues for is, that processing data and basically these chaining together these tasks that I don't need to tell the user when it's done because they don't need to worry about it. So the cold start I see as something to be aware of when we're doing HTTP triggers, but with like blob storage triggers, queue triggers, all these other triggers that aren't initiated necessarily by a user. These are things that are just kind of happening in the cloud. Then yeah, I don't really care if it takes 10 minutes for this queue to start up because it doesn't matter to me if this queue finishes in a minute, in an hour. It's just kind of like, I'm going to queue this up. And
totally. And it doesn't affect, like you were saying, doesn't affect the the user. They don't need to know, don't have any visibility into a lot of those things. And quite honestly, like if you really wanted to come back and like say, well, does this, impact our business? Does it bring value to the customers? Like all the things that we're trying to do. No, it does until like whatever it is you're delivering, that service that you're building, until it is impacted by that cold start.
Exactly.
And your users can tell that it's just not, it's not something that an SRE would care about. It's not something we're going to build a, some sort of monitoring around until it becomes clear that this is part of the business logic. Like this is what drives this thing.
Yeah. And I think that's probably the best way to put it is, does it impact the business? Because certain businesses would be impacted by a cold start. And I always think about companies like Amazon, Walmart, their online stores need to be running 24/7. They need to load as fast as possible because they literally have data that show if a transaction takes longer than 3 seconds, they're going to lose this amount, this number of dollars, this many dollars. They're losing money every second that the website takes to load. Yeah. And so if that's your business, then yeah, cold start's going to kill you because that 1 second could mean, and I don't know what their numbers are, but let's say $5,000. So yeah, maybe you pay for the premium tier where there is no cold start because the premium tier would be cheaper than the revenue lost. But yeah, I think that's probably the most important thing is how does it impact the business, and
absolutely
then kind of go from there.
Yeah. I just had flashbacks to like the SRE world of, like if we're gonna put some engineering effort around this, there's got to be value in it that goes to the end user and solving a problem, that kind of thing. So, all right, well, this has been awesome getting caught up on all this stuff, but I don't want to take too much longer because I think we're about 20 minutes in now. Do you want to switch over and we can start putting hands on keyboards here and actually talking about some of these queues and stitching things together?
Absolutely. Yeah. If let me know when you can see my screen and we'll get rolling.
Let's add you in here.
Cool.
Should be good.
All right. So just want to show off an example first of, we've been talking in the abstract a lot about why we use queues, how to use queues. And so I thought it'd be helpful to show, this is an open source repo that I made. And it's kind of funny. But like I said, I'm a mobile app developer. So that's kind of my expertise. That's my bread and butter. And then my foray into the cloud has always been like, what cloud services do I consume as a mobile developer? And so one of the things I made was this app called TextMood. This is available on GitHub. So brminix/TextMood. And what this does is it actually leverages Twilio. Jason, have you ever used Twilio?
I have. I used to use it like quite a bit actually when I was at my previous job and loved it. There were so many cool things you could do.
Yeah.
And then at some point there was a friend of mine that was working there and I got to go visit the San Francisco offices and learn even more. There's just so many cool things that Twilio does. I feel like in general, when you go look at Twilio, there's a lot of interesting things that they're doing and their marketing and everything, branding is like amazing, but they also fly under the radar for a lot of people in terms of the services and like the really cool things you can do, especially around SMS.
Oh yeah, and that's actually what's going on here. Beautiful
Nice.
segue, by the
Nice. Nice.
way. Master host. Um, so yeah, I made this app that if you were to text me, so like Jason mentioned, Twilio does a lot of telephony services. So you can, for example, you can buy a phone number on Twilio, or you can use that phone number for phone calls, for SMS, whatever you want. And I think one of the biggest examples, I don't know if they're still using it, but I know a couple years ago when I was first learning about Twilio, I found out that Uber actually used Twilio. So like when you order a car on Uber and it says like call the driver or text the driver,
Yeah.
and vice versa for the driver to call and text you, they're just given the app just gives you a random number. So like the driver never sees
Right.
my phone number. They see this Twilio number and then
Yep.
Twilio forwards it to me. So it's a way to keep that privacy.
Definitely.
And I'm not sure if they're still doing it today. That was back when Uber was smaller. Maybe they've created their own Twilio internally, but
I ran into that when I accidentally left some luggage in an Uber, and then
Oh, yeah.
had tried to reach out by calling the number that they texted me, and it didn't go through.
Yep, you'll learn that one the hard way. But yeah, so what I'm using Twilio for in this app called Text Mood, is so I bought this Philips Hue light bulb. That's what we see at the end of this chain.
Mhm.
And I thought, wouldn't it be cool if anytime my wife texted me that I could run that text message through some sentiment analysis that you can do in Azure using cognitive services. And then I could send that to an app on my phone, and not just the app on my phone, but also to this Philips Hue light bulb. And so both the phone and the light bulb would change from green to red based off the sentiment. And so, little things like, well, let's be honest, I'm an engineer. I'm really good at data. I'm really good at numbers, math problems, puzzles. But reading emotions isn't one of my strong suits. And so things like my wife would text me like, did you pick up the groceries? And I would read that and be like, oh, wow, she must be so mad at me. I totally forgot. When in reality, she was just on her way home from work and offering to pick up the groceries if I hadn't already. And so this was just a fun app that I made to play around with this stuff. And I think I don't know if it'll show up too well on the stream, but this is the light bulb and then this is the app. And we'll see them slowly, as I send more happy text messages to myself, it'll slowly turn greener and greener and greener. And, but the point of this and the stream today is that this uses queue triggers and queue outputs and Azure functions.
Yeah.
So yeah, what I'm doing in this app is that SMS actually goes through Twilio. Twilio forwards it on to a HTTP trigger, so an API, but this is, again, Serverless Azure Functions API. And all that API does is do the sentiment analysis. So it does the machine learning stuff and says, is this text happy or sad? Excuse me. And then when it's done with that, it puts that information onto a queue. And there's another Azure function with a queue trigger that all it does is save it to the database. So we have this just microservice, couple lines of code that will save it to the database as soon as it sees anything hit the queue. And so that's great because the way I did the colors, I did it over a 1 hour average because I kind of figured emotions don't really swing back and forth immediately. Like nobody's going to be like, oh, Jason, I hate you. You're the worst. And then 2 seconds later say, but you're the best guy in the world. So yeah, it's just using like a running average over an hour or so.
You haven't been on social media much lately, I feel.
That's fair. Oh man. I'm trying to unplug a little bit, especially now that election season's over in the US. I don't have to like be a informed voter for at least a year. So yep. I'm enjoying like a month off and it's been nice. But anyways, so yeah, queue trigger, we'll store it to the database. And then there's another queue trigger to send the updates to my Philips Hue light bulb here in my house. And so if you're looking for just an example of how you could use queues to chain together microservices, here's one. Feel free to check it out. It's totally open source on GitHub under brminic/textmood. Okay, but that being said, we're gonna create everything from scratch today, because what better way to do a demo than to just wing it, right?
And also, I just dropped the link to the repo that you were referring to. I put that into our chat.
Oh, awesome. Thank you. So yeah, in my, this is Visual Studio for Mac. So I'm just going to tell it to create a new Azure Functions project. And let's see. Let's actually start with...
good catch. Let me drop that link again. I put it in the wrong place. Hang on a sec. But go ahead.
No.
I just realized it got masked.
So let's kick this off. Let's leave everything anonymous. Why not? And cool. So what I'm going to do, I'm going to start with an HTTP trigger. And I know that's not what we're talking about today, but I'm just going to use this as like an API endpoint so that I can pass in data, and it'll make a little bit more sense once we push this up to the cloud. So let's see. This will just,
is there any way we can go a little larger on the font?
Absolutely. Yeah. Thank you. Increase the font size here, font size there. All right. So let's get that set up. All right. So the first thing we want to queue up is we need to add in this extensions NuGet package. So this Azure Web Jobs extensions storage, this is what's going to give us the ability to do these queue bindings. And so like you can see that this is using other libraries under the hood, one of them being Microsoft.azure.storage.queue. And so that's what we'll be taking advantage of. But yeah, if you wanted to do like Cosmos triggers or blob storage triggers, they all kind of come in with this as well. And you'll probably see the word web jobs a lot when you're playing around with functions. Don't worry too much about that, but probably the best way I can describe web jobs is web jobs were functions before functions. Like web jobs had a lot of similar functionality in the Azure cinematic universe, but it's kind of what functions grew out of, or web jobs grew into functions. So yeah, don't be confused when you see web jobs. If you're just working with Azure Functions, then you can just replace that mentally with with the word functions, and it's pretty much the same thing. All right, so we've got our HTTP trigger here. Now we can do our queue output. So actually, let's bring up some docs first. Let's show off what are we doing, because
is this the doc that you had sent me earlier?
Yeah, this is the one, or it should be at least, the Azure storage queue with
grab that link
Azure Functions. Appreciate that. Thanks for cleaning up my mess. So what I want to show here is, how do you output to a queue? Like, how do you put something onto a queue? What does that require? Because it's pretty easy. We just have to add in just a couple lines of code to our function, and one of them being this iCollector. When you start using functions and you start doing a lot of outputs, because you can do blob storage outputs, you can do queue outputs, you can do Cosmos DB outputs, you can do all sorts of outputs. Actually, speaking of Twilio, I think Twilio is even integrated into functions, and they've got Twilio triggers and outputs now, which is cool. But to do these outputs, you use this data type called iCollector. And iCollector is just like essentially, well, it's a collection. I was going to use the word list, but list is something in C#, but it's like a list that you can just drop anything into it, and Azure Functions will handle everything else for you. So Azure Functions will automatically put it on the queue. You don't have to worry about anything. And what's really cool is, let's bring in some of this code. So actually, I was just thinking to myself, we were showing off this text mood app. Why not actually look at that existing code, both so we can see it, but also so I can copy paste and not have to worry about typos. So with this, we have a queue attribute that we're about to add here. And this is the iCollector we were just talking about. So with this queue attribute, this is just where we define the name of the queue. So this text mood app, for example, I just have a bunch of string constants, but we'll just pass in a queue name here, and then we'll create an iCollector of any type we want. And what's really cool is that the Azure function will automatically serialize and deserialize things to and from the queue for me. So let's call this just first queue. be very descriptive. And so iCollector can take any type, and maybe we do, let's create our own type just for funsies to show, because we could just make this a type string and we could just pass strings back and forth. But what's really cool is to see how it handles objects, because it just works. This is one of my favorite things with functions. So let's create an All Around Azure class here. And we'll just say public string, let's say show name, get set, and public int show number, get set. And so now we can use that as our type here. And then let's see, this will be our, let's call it first queue collection. So, comma, get rid of that red squiggle. All right. So I'm going to delete most of this code. This was just the templated code that came around when I created this. And we'll keep the return result. We'll just always send back now we can do an object response. So let's just go ahead and create our new, let's see, what are we doing? This is our queue trigger all around Azure episode. And we'll call it queue triggers. And you said this is what, the 55th episode, Jason?
Can you believe that? Episode 55. Yeah. So while I was sorry, I put the link in chat for everyone there, shortened it up for everyone, and dropped that in there. But while I was doing that, I was a little distracted, and I didn't see it. Are we doing .NET? What language are we in here? I totally missed that.
Good question. It's all C#.
C#. Okay.
I only do C#. Well, we'll say it's a blessing and a curse, but yeah, C# is my favorite language, and it's getting to the point now where .NET has expanded. Like, I make native iOS and Android apps using C# and Xamarin. You can do IoT stuff, you can do desktop apps, you can do web apps, you can do serverless functions. So I'm kind of running out of excuses to ever leave C#, which might be dangerous. Who knows?
That's true. That's true. I'm trying to expand out. I'm learning TypeScript now. Fridays are dedicated to learning TypeScript. Cool. Yeah, trying to expand my beyond YAML and JSON.
Oh man, yeah, I feel like JSON's just like that universal language that we all have to learn, and YAML is one of those, like, you can choose to learn it, but eventually you're going to run into it. So
exactly,
all good stuff. So I created the All Around Azure model, and I'm going to send that back from my HTTP request just as a result, just to let the user who called this HTTP trigger, just let them know we created something. But before I finish this function, before I finish it, I'm going to add this object to the queue. So what's really nice, and we'll see this once we get this all published up to Azure, that this will actually serialize my object for me, turn it into JSON before putting it on the queue. And then when we have our queue trigger listening to pull it off the queue, it'll also automatically deserialize it. So there's a lot of extra work that's just kind of done for us that we don't have to worry about.
Right.
And so why don't we do this? Let's go ahead and let's get this published up. Hopefully I've got all my Visual Studio stuff set up.
I'm going to push it right into Azure, straight through Visual Studio.
I was just going to push it live here on the show. Yeah, through Visual Studio.
Just deploy it. Yep.
Hopefully it'll let me. It's a blessing and a curse to be a Microsoft employee, because we get to use Azure. We get a monthly budget for it, but because there's a monthly budget, then they have to make rules around that. And so sometimes I go over budget and sometimes the tools get mad at me. So we'll give this a minute to let this new button be enabled. It's still loading. Also, another blessing and curse of working at Microsoft is there's just tons and tons of these resources in Azure. And so it has to load a lot of stuff.
Yeah.
That me and you and all our colleagues have
a lot of stuff, a lot of cruft, I'd say too.
I know. The best is when you get these emails and they're like, hey, you haven't used this Azure resource in a year. Can you delete it? Like, whoops.
Resources.
Totally forgot about that. There it goes. Okay.
Never happens to anybody. Governance isn't important at all.
So we got our queue storage demo. Let's go ahead and create a new resource group here. And let's see.
So yeah, the text is a little tiny. If you could guide us through what you're seeing a little bit.
Oh yeah, sure.
Just for those who haven't seen this familiar. Oh, there, that helps.
Does that work? Okay, cool.
Yep, that's great.
So the couple things we have to do whenever we're publishing, whenever we're creating a new Azure Functions app, is, let's see, actually, let me make sure. Do we have consumption? Okay, cool. So, yeah, whenever we create a Azure Functions app, it uses the name of the app as the URL. So when I name this queue storage demo, probably what I should be doing is make it a little longer, like All Around Azure. Hopefully nobody's used that before. There we go. So the warning sign went away. Mm-hmm. And once we have the name's been validated that nobody else is using this name yet because it's got to be the URL. Yep. Then we have to put this somewhere, and Azure calls everything a resource. So if you create a database in Azure, that's a resource. If you create a website in Azure, that's a resource. And oh yeah, sorry, I skipped over subscription. So this is just the account that you use to pay for Azure, essentially. So this is my internal account. So that's what I was saying earlier. Like, hope it works. Hope they don't yell at me. But I'm sure it'll be fine. But yeah, with resources,
only in the middle of the month, we should be good.
I know, right? It's like, yeah, the end of the month is where things get interesting, at least for me. But yeah, so Azure calls everything a resource. If you create a database, that's a resource. If you create a website, that's a resource. And they have these things called resource groups that is basically just a folder for your resources. So I use this like for my mobile apps. All the infrastructure I need for my cloud backend, I'll put that in the same resource group. So like Git Trends has its own resource group. And so, yeah, I'll just make a new one here called Queue Storage Demo Resource Group. And then your service plan, this is where we get back into talking about money and stuff, right? So there are different pricing plans that you can use. And we're going to go with consumption, because consumption aligns with everything we've been talking about. Consumption means we will only be consuming resources when they're in use. When this Azure function is not being used, spin everything back down to 0. So that's where we get the cold start, because we spin back the resources down to 0. But that's also where we get like the super cheap Azure
Totally.
bills.
Yeah, that's the trade-off, right? Is that you don't have to pay much. Yeah, exactly.
Yeah, and so if you wanted to, sure, you could have a dedicated one-core processor and 1.75 gigs of RAM, but we're going to flip down to consumption because we're doing everything serverless. And if you wanted to, you can also select your data center. Azure's got, I don't know, 50, 60 data centers around the world. Choose the one closest to where your users are going to be. That's always my recommendation, because data can only travel at the speed of light, or everything travels at the speed of light. Wait, everything is limited by the speed of light. There we go. And so
it can only go so fast.
Yeah, and so if I put this in Australia, well, I live in California in the US on the West Coast. And so if I put this in Australia, there's going to be a round trip time for my computer to reach the server in Australia and come back. That'll be a couple hundred milliseconds. Whereas if I put it in, say, the West US, which I think is here in California, then it'll be like a 10 millisecond round trip time. So yeah, choose the region that's going to be closest to your users to avoid that round trip time latency.
Mm-hmm.
Okay, so we click next. And then the next thing it's going to ask us about is a storage account. I'll show you what this looks like in Azure. It'll make a little bit more sense. But when you think about the fact that we don't have a dedicated server with dedicated CPUs, dedicated RAM running 24/7, the question kind of becomes like, okay, well, where do we store all the information about this function? Because like I'm writing code right now, and this code has to be stored in the cloud so that when the serverless function is triggered, Azure can quickly pull my code, spin it up, get it up and running. So it does that by putting everything into Azure storage. So you also get for every Azure function app that we create in Azure, we also need to have a Azure storage alongside of it. But again, the costs are just super, super low, basically free. So wouldn't worry about that too much. Again, unless you want to like crank it up and make like this is like globally redundant storage, and you can always, Azure will always let you pay more.
True.
I don't think they'll ever say, no, don't pay us money. Like if you want to do something in Azure and you want, like I saw a virtual machine that was something like, I forget the exact number, it was like thousands of dollars a day, but the thing was a monster, like just more RAM than I could ever dream of. But anyways, let's go ahead and click create, because that's going to take a couple minutes to push my code to Azure, publish this on Azure. And that's kind of what Visual Studio's let me know here. It's like, hey, just FYI, we're doing this in the background.
Yep.
And let's see. There should be a window. Yeah, this Azure window here. So we can watch all this stuff happen. And this is just logs letting us know that it's doing stuff in Azure and it's still doing stuff in Azure. Things are succeeding, so that's good. But yeah, in a second.
Nothing's red.
Yeah, I know, right? Nothing's blowing up. But yeah, in a second, we'll see my browser will pop open, and that'll kind of let me know that everything's done. But while that's going, actually, let's keep pushing forward.
Okay.
Because I don't want to lose track of time. We can always come back for questions.
We're good on time. Yeah, we got plenty.
Right on.
And I've been watching the chat, so no questions really so far. Nothing that we haven't already addressed. People love your laugh, so so we'll keep making you laugh. And but yeah, definitely if you for those of you still for those of you watching, if you have questions still, definitely drop them in the chat for us.
Love it. So yeah, what I'm going to do now is I'm going to copy paste some code because I want to get these names right. But basically, I'm going to create another function. Still stuff going on. It's still building. Okay, good. Everything's still working. Nothing's blowing up yet. Oh, now it's publishing to Azure. So here is where we can create. Let's copy paste this code. You can be a static class. Why not? So when we create these functions, you have to give them, you name the function. Oh, and there's my browser popping open. Cool. Let's go with this this quick aside here. Now that the function's actually in Azure.
Okay.
We'll come back to this Q code in a second because I just want to show you.
We'll pop into the portal and take a look at it.
Yeah, like what's going on, what happens, and I want to call this this HTTP trigger to show the queue. So let's see, what did I call it? Queue storage. I just saw it. I'm so bad with typos. Queue. There it is. Whew. I know. My mom's an English teacher. She would be really disappointed to know that.
Mom watching?
I spell everything wrong. I don't know. Maybe. Hi, Mom. She says she does, but at the same time,
we'll forgive
she
you.
also says she has no idea what's going on. So I appreciate her support, but don't feel like you need to watch me, Mom. All right. So this is what we just pushed to Azure. This is our queue storage demo.
Excellent.
Let's make this a little bigger. So HTTP trigger, it's enabled. It's running right now. Everybody that's watching alongside of us can actually play around with this, which is both terrifying and cool at the same time. But yeah, we have our function URL here. So let me open Postman. Postman is just a cool desktop tool that you can use to play around with APIs. Highly, highly recommended if nobody's used it before. But what I'm going to do is use Postman to make a GET request to this API. So this HTTP trigger that we just wrote, just to show the code real quick, let's do this. So this HTTP trigger that we just wrote is going to run in the cloud. It's going to create this new All Around Azure model. It's going to add that to the queue. And then it'll also return an HTTP OK status code back to us with the data in the returned result. So let's do this here. Boop. And I think I can make this bigger. Yeah. All right. So if everything works, when I click send, yes. Okay. Awesome. So it sent back the result. That was the All Around Azure model that we created. That looks good. Q trigger, show number 55. And what we also know, since we wrote this code, before it sent that back to me, it added the data to a queue. So in Azure, I've got this data stored in a queue now. And what does that mean, right? Like, where do I find that? Where do we go looking for this? So let's jump to our resource group, because the resource group, like we said, this is just a folder to store your Azure resources that are, and I use it to store things that are related. So this is where we can see our Azure Functions app that we're just playing around with, and our storage account. So this storage, yes, it saves my code. So this is where it stores the code when it's not running, and it knows how to find the code and spin it back up. But it also just comes with a queue. And so if I click into this queue, check this out. So this name here, first queue. Well, guess what? That matches the name that I created here. So first queue. And if I click into it, everybody around the world is also hitting this API endpoint. Thank you. Because we have we have a couple of things queued up. I was expecting to see one, but your viewers are on top of things. So
it's the risk, man.
No, I love it. There's nothing wrong with it. Keep hitting it. Let's see if we can break Azure. Like I said, if I run out of my monthly Microsoft Azure stipend, I'm happy to do it because we did it here on the show.
There you go. We have some big plans for this show, Brandon. blowing up Azure Functions is just the start.
Whoops. Yeah. So anyways, so what it did, it took that C# object. So let's see if I can view these side by side without, yeah, beautiful. So it took this object, like I just created in C#, I just created an object called All Around Azure model. I passed in some data, and what Azure Functions did, it added this to the queue, but first it went ahead and serialized everything. It even added some information like this Azure Web Jobs parent ID, so it knows where it came from. Again, web jobs, anytime you see web jobs, just replace that with Azure Functions in your brain.
Yeah.
That's what I do. Unless you want to like go back and understand the history of everything that everything came from, which is sometimes fun too. But it gave it a unique ID. It gave it an insertion time, and oh yes, there we go. So it also has an expiration time, and this literally means it'll expire in a week. So if my queue trigger doesn't pick it up in a week, it'll disappear. But these queue triggers pick it up almost instantly. If not milliseconds, then seconds. I've never had a problem with that. But where this comes in is this DQ count coupled with the expiration time. So sometimes what happens is your queue trigger will pick this up off the queue, and the code will run, but it'll throw an exception. Like the code crashes, right?
Yeah.
And when that happens, Azure Functions, being the helpful tool that it is, will put this object back into the queue where it pulled it from, because it knows something unexpected happened, and we shouldn't assume that this data was handled. We shouldn't assume that this data was processed. So they'll dequeue it and put it back in the queue. So you'll see this number go up if you have a queue trigger that just keeps failing. And so
if you saw a queue count of obviously more than one, but at what point would that queue count, that DQ count, be alarming to you?
Yeah. So there's another cool thing that Azure does with these queues. If it gets dequeued 5 times, it'll put it into what's called a poison queue.
Huh. Just send a timeout.
Yeah, I don't know if I have an example of this. Let's do a quick aside. Hopefully none of my code is what do I call it? Verify GitHub links. Oh, it exists. Take my word for it. But yeah, what you'll see is if we jump back into, so let's go back into where all the queues. So as we add more queues, we'll see more queues here. But yeah, if that queue trigger failed 5 times, you'll see another queue below this called first queue -poison. And I love the name. I love the idea of like this poisonous queue. Like, this is poisonous data. Our server keeps crashing. But what it does is it just essentially moves it from first queue into first queue -poison, or maybe it's poison -first queue into this. It moves into this poison queue. And then I can come back the next day and check on my server, right? And I see all these errors happening, or my server's crashing. And then what that allows me to do is fix the bugs, get it up and running again, push it to Azure. And the good news is that all my data was still there. So if we were making an Instagram clone and users had uploaded all their files and we had them all queued up, but it kept failing, well, all that data is still here. It's just in the poison queue. And then we can kind of fix the bugs and move stuff off the poison queue, but keeping in mind that there is going to be this expiration date. So yeah, I mean, if you check your stuff about once a week, or maybe every Monday morning, you just double check things. Or, I mean, you can set up tools like Application Insights to monitor this stuff for you, which obviously we're not going into that today, but
we can in the future one. I would love that. I've spent quite a lot of time actually, I should say, with Application Insights.
Yeah, I was gonna say, that's your expertise.
Teach me how to do that. It's my comfort zone. I don't know about my expertise, but it's what I was going to say is that I have not currently, I don't have an Azure function I've tried to monitor, and I've tried to set it up to be monitored the way I think it should be. Anyway, it would be really interesting, fun, I think. So maybe for part 4 or 7 or whatever down the road.
Because I mean, I just rolled out that internal tool to our team.
Right.
It uses a ton of Azure queue storage and queue triggers. And yeah, I would love to have some monitoring around that. I just right now it's just me sitting at the computer like refresh, refresh. Okay, everything looks
No, you
good.
don't
Oh
want
wait,
that.
refresh.
You want the system to tell you when there's a problem, but only when there's actually a problem you need to do something about.
That's right. Okay, so we've got all these queue messages queued up. It did it all automatically for us. Like the only code we had to write was basically creating this iCollector, defining a class, and then you just say .add, and then everything will just magically appear there. Happy days. So what do we do now that we have all this data in the queue? Well, we should have a first queue trigger. So I'm going to delete this HTTP trigger because I want a queue trigger. And actually, I think we have some docs queued up for this. Well, I should have had this queued up. Let's see, queue trigger.
That's all right. While you're getting that ready, I'm gonna get something up on the screen here. we've created a poll over on Learn TV for anybody who wants to come chime in on that. What language you like to work with especially when it comes to Azure functions. So if you want to pop over to Learn TV and check out that poll, we'd love to get your input on that.
Yeah. And actually, speaking of languages, you can see a couple here, and there's more. I think there's more than this, like C#, JavaScript, Python, Java, and I feel like there's a couple more. But like I said, I live in the C# world, so maybe not. But yeah, all we have to do now is kind of similar to what we did before. Like we had that queue output. Well, now we're going to flip it. We're going to create a queue trigger, and we're going to tell it which queue to watch. And then we're just going to tell it what we expect off of this queue. So I have my queue trigger here, and let's get rid of all that other code. And this is what I copy pasted. So I copy pasted first queue. That way I know no typos, happy days, hopefully. And add that curly bracket, add in some using statements, get rid of these red squiggles. And I don't even think I need an action result. So the difference here compared to our queue output, the queue output needed this iCollector, and this allows us to add as many, we could have added 10 All Around Azure models to the queue if we wanted to in this one function. We're only doing one, but like in that internal tool, I do something like, I say like, give me all of Jason's GitHub repos, and then one by one, I add them to the queue, and then they all get processed all serverlessly. I love it. And so, all right, so that put it onto first queue. We're going to pull off of first queue. But the way these queue triggers work, we're not pulling off all of them. We're just it just pulls off one at a time. So All Around Azure model. And so again, this is going to trigger automatically anytime it sees new data added to first queue. It's going to pull off the first thing in the queue, and it's going to automatically deserialize it, turn it into a C# for us. And now we can do whatever we want with this. We could do something like, I don't know. I guess we could put it onto another queue. Yeah, let's put it onto another queue. Why not? So it's a queue trigger with a queue output. And we'll call that second queue. Okay. So we only have an hour with everybody today, but yeah, the idea would be, this would be the next step in our microservices. Let me change that function name before I forget. But yeah, this would be the next step in our microservices. So that text mood app I was showing off earlier first did machine learning sentiment analysis and then added that object to the queue. Then we had a queue trigger that pulled it from the queue and saved it to a database. Or we talked about if you uploaded images, we want to maybe turn those images into thumbnails, into scaled resolutions. And so that could be the second task in our microservice. And you can kind of have them, so you can have one Azure function output to a couple different queues, and then you can have all those queues just spin up automatically using queue triggers. So, I mean, we're working with this all around Azure model here. So maybe we do something like, and let's change that variable name too now that I see it. So let's change it to show name equals, what the show name really is what? All Around Azure Serverless Part 3 queue triggers.
The serverless saga continues.
I know it never ends, but it's always just because I love this stuff. It's so easy to use. Like, I don't know. Could you imagine handwriting all this code to like handle queues and events and publishing and subscribing to that and like doing the serialization and like this poison queue stuff where like if things fail, like handling like those failure cases. It's just so much stuff that is just done for me. And when we use the consumption model in Azure Functions, it's also pretty much free. So I don't know. Thanks, Azure. I don't know how you're making money off this, but I love it. Okay, so we'll just tweak the show name, and then let's send that to our second queue. And maybe we do something else. We could tweak the show name again. Let's shorten it up, and then also add that to the queue. So this is going to output two things to the queue, which is going to be kind of cool. We'll see how this works in Azure. And what's also cool is as soon as I push this can just be void. Get rid of that squiggle. As soon as I publish this to Azure, then it's going to trigger. Like, we don't have to do anything. We should see first queue disappear, and we should see second queue just explode with data, assuming we did everything right and there's no typos. So, just goes.
And our viewers didn't blow up. And our
viewers
didn't blow up the function.
That's right.
Didn't DDoS us.
Oh man, I'm gonna get a nasty email. It's like from the Azure security team. Please don't do that again. All right. So the good news is
signed red team.
There you go. Oops. We had fun and we all enjoyed it.
We all learned something.
So the good news is that was really quick. You notice I clicked publish and it just happened almost right away. And that's because the first time took a little longer because I didn't have an existing Azure resource. I didn't have the Azure Functions, the Azure Storage, anything like that. And so since that already exists now, all Visual Studio is doing is just uploading my code to the cloud. It's just like, what code changed? Upload it. And oh man, now I'm nervous. Let's see what happens. So let's first check that we have two functions here. Loading. Cool. So we have our HTTP trigger and now we have our queue trigger. So that's the one we just created. And let's see, jumping back over to our queues. Loading. Waiting for these 3 dots to go away. Take your time. Refresh the page, force it. There we go. So there's my resource group. And there we go. Storage. Okay, so jump back into our queues. Awesome. So now we see 2 queues. And again, we didn't create these queues. I mean, you can manually create queues. You can do all this queue stuff without Azure Functions. So I should have said that at the top. If you're just loving queues and you want to manually do all this, go for it. I cheat. I use Azure Functions because it just makes everything super easy. All right, so if we look at first queue, hopefully there's nothing here. Yes. Okay. So we have no results. When we were in here a minute ago, we saw, I don't know, what was it, like 20? 20 messages in the queue. And I clicked the wrong button. All right, let's go back to the queue because I don't know how to click buttons. All right, so now in second queue, we should see double the amount of messages that we had before with we see the show name. That's our long show name. Hopefully we see some messages with the shorter show name. Yep, there it is. And so yeah, we just had a queue trigger. Let's show this quick recap with stuff side by side. So this was a queue trigger. It was monitoring the queue that I named first queue, very specific.
Uh-huh.
And what it did for me, it automatically pulled off any messages on that queue and automatically turned it into this All Around Azure class, this C# object that I could just use and manipulate. And so manipulate in a good way, leverage. So it pulled it off. We changed the show name to be a lot longer, a lot more specific with All Around Azure, Serverless, blah, blah, blah. It's getting cut off. It's so long. Mm-hmm. And we added that to a second queue. And then we said, why don't we change the show name again? Call it just queue triggers and queue outputs, and then also add that to the queue. And what we're doing here is almost this fan out effect. So we have one thing that triggers our serverless function, and then that fans out into triggering multiple functions, because we could create a second queue trigger and that'll run automatically for both of these messages now. So we essentially went from like one queue trigger that put two things onto the queue, and that will spin up two queue triggers next to it. So it's a really cool way to fan out, scale. I do this a lot because everything's serverless, so you don't have to worry about how much CPU or how many cores do you need, how much RAM do you need. You can just kind of tell Azure, like, yeah, go crazy, just handle it. Just make sure you spin down all the resources when you're done.
Absolutely. Cool. Well, I have never seen this demo in action, so and I've always wondered about how the queues actually work out. So that was really
it is really cool, and you can kind of see. Yeah, I keep talking about this internal tool, but I mean it is open source. So just to show this, because I'm just kind of pretty proud of this architecture diagram.
It's an impressive project overall, yeah. Definitely show it off.
So this, you kind of get a sense for that fanning out. And so what this tool does is it basically double checks all of our GitHub repos on the team to see if there's anything missing. And if there is, it'll add it and open up a pull request. But for doing this, there's, how many people do we have on the team, Jason? Whoa.
100, over 100, I don't know.
Oh, so over 100. So the first step, I have this timer trigger. So if you see this little clock versus a little queue trigger, but this timer trigger runs once a month, and it'll get the data for everybody on the team. So it tells me, first, your name is Jason Hand. This is your GitHub account. This is your Microsoft alias, your email address, blah, blah, blah. All that data is just what the first Azure function does.
Okay.
That seems a little too much. And then it just puts all that data into a queue. And then I have the next function. This is a queue trigger. So just like we created today, this is a queue trigger that will take that information just got, and for each advocate, so for all 100 plus of us, it goes to GitHub and says, get me every GitHub repo that Jason owns. Get me every GitHub repo that Brandon owns. And so as it gathers those GitHub repos, it adds them to the queue. So this is where we fan out massively, because we went from about 100 advocates in this queue to, I think on average on our team, we have 50 to 100 open source repos each.
Yeah.
So multiply the 100 advocates by maybe another 100 repos. That's 4 zeros. That's 10,000 queue messages that this then creates. So this fans out like crazy.
Yeah.
And then it does some more stuff to check the README, verify that we have some data in there. And then you can also see it kind of start to spin back down, because as it does the verification, it doesn't need to next add or to queue up the next thing, which would be to open a pull request for the repos. So what's what I love about this is the code for this is pretty minimal because the queues just handle everything. It handles all the serialization, the deserialization. It handles the poison queues we talked about earlier, where something doesn't work and it fails. What do we do with that? It handles the scaling. So, we're talking about running 10,000 queue triggers, like almost simultaneously. And I didn't have to do anything for the server side. I didn't have to say, oh, let's see, if I'm running 10,000 queue triggers, that's probably going to require the app needs 40 megs of RAM. So times 10 that, like, I didn't have to do anything. It just automatically will expand and grow to the scale that it needs in order to execute. And then when it's done, it automatically just scales all back down to 0. So yeah, like once a month, this tool runs and spins up just a massive amount of Azure resources. The code I had to write was pretty minimal because we're just leveraging all these existing queues and stuff. And then when it's done, all my resource usage goes back down to 0. So if we look at the Azure bill for just this tool, we'll see a spike on one day a month. And again, that's just, you get so much for free with Azure Functions that the bill is almost nothing. But once it's done, it just spins back down because it knows we don't need to run any of these resources for another 30 days. So this was,
so is this all
like peak queue triggers?
and I'm guessing this, just like we were showing today in the demos, like this is on a consumption plan and that kind of thing. So that's a big part of the scalability comes in.
Yeah, exactly. So yeah, the consumption plan will just consume what it needs to consume. And so what's really nice here is, we talked a little bit earlier about these, what we call like background jobs running in the cloud. So scaling images, or for that text mood app, like saving stuff to the database, things that like the user doesn't need to worry about because all they need to know is like their photo uploaded. So you can just say, hey, we got your photo, you're good. And then they know that eventually my photo will appear on, say, Jason's timeline. And so, yeah, what's cool about this is, each function's going to have cold start, but like, I don't care about any of that because this is just running in the background. So I will say one cool thing about cold start is that there's only one hit for the cold start. What I mean by that is when this function runs, like this will run about 100 times for everybody on our team. And the first time it runs, like the first advocate that it pulls off the queue, that will incur the 1 second cold start overhead. But the second advocate it pulls off the queue, because the function's already running, it's already been spun up, the resource is already there.
Yep.
There's no cold start time. So that cold start is just for that first one. And then it'll just continue on and it'll scale up all on its own. So yeah, that is, we'll call it a trick. If you want to avoid cold start stuff, like I mentioned, when my Git Trends app launches, it first makes a call to Azure Functions. Well, that also wakes up my Azure Functions app. And so the next call to Azure Functions doesn't incur that 1 second cold start time. And again, I forget the numbers, but there is essentially a clock that runs. And I forget if it's 5 minutes or 10 minutes, but once you spin up the function, it'll be alive or maybe it'll be warm. That's probably a better word to use. It'll be, so you'll endure that cold start, that 1 second overhead for the cold start, but then it'll stay warm for, I think it's 5 minutes or maybe it's 10 minutes. And so if my same mobile app calls an Azure function again as its API, then there is no cold start penalty. So just more things to be aware of, like be aware.
Yeah, a lot of it's just that the architecture of how you design things and the order of things to happen. And I love this stuff. So Brandon, we've got like 10 minutes or so left before we're all done here today. So I'm going to drop a link into chat for both you and our guests. And this is a link into one of our Azure Functions Learn modules. So Brandon, if you could pull that up. I called an audible. I hope you don't mind. You had shared with me a link earlier that we might talk about here at the end of the show on Azure Functions. But I wanted to pick a different one. I think we've done that one before. Maybe not you and I, but I feel like that one's been done before. So if you want to pull that one up, and we'll just spend just a few minutes taking a look at it here. Let's switch back over to you, dude.
Yeah. Do you remember what it's called?
Did that link come up
for it here?
So execute an Azure function with triggers.
Ooh. Yeah, that one's.
And the reason I picked this one was specifically last week, I think, was when we were going through this. So yeah, if you could zoom this in real quick here, let's just go through it a little bit. The thing I picked out, the reason I wanted to talk about this one, even though it may not be super relevant to the queues and stuff like that, we talked about today, the stuff we talked about last time definitely it relates to, because we were doing a lot of what I was referring to as cron job type of triggers, just timer triggers. Mm-hmm. And so, so let's scroll down through this. And I just kind of want to point out some of the highlights for a few minutes here before we wrap up, because I think this is a really, really good Learn module. So do me a favor and scroll down towards the bottom here. I just want to kind of point out a few things.
No problem.
So yeah, there you go.
Quick shout out to Learn. This stuff's relatively new, but basically what Microsoft did was Microsoft a couple years ago realized, like, we have all this learning material, but it's scattered across, I think it was literally 80 something domains. So there was learning materials over here, learning materials over there. So what they did, they brought it all together under Microsoft Learn. And I think the coolest part about Learn is, like, it's just totally free. You don't need to create an account. You don't need to put down a credit card. This is all just free materials that if you want to learn how to do Azure Functions like we're doing today, you can do it. And you can even get, like, if you do make an account, then it'll track your progress. Like, you see me here. I'm level 6.
Level 6.
I'm not sure what level 6 means, but I'll take it. And
that's just above 5. But you're doing well. You're doing good. You're doing good.
Yeah, like you get badges and trophies and stuff. I don't know if this will. There we go. So, like, all my achievements and it's all Xamarin stuff. But yes, so
yeah, I love it. Amen. This stuff is so fun. I do at least one Learn module a week. Just
oh wow,
usually very in preparation for a show, but also just because I'm constantly pushing myself to do more stuff, like I mentioned, learning TypeScript and all kinds of stuff really lately. So, but to your point, they've taken, and something I really wanted to point out in this here in the overview and the agenda is not only Learn module is going to give you a lot of information that you can read, of course, and there's some videos in there, but the exercises, I think, is where it sets itself apart, especially as a free tool, because if you go in, let's just pick one of those exercises, if you don't mind.
Done.
And so what happens is it creates a sandbox for you, and you can decide, now this varies depending on what the Learn module is, but you get the choice of, as you can see here, you can choose your own development language. You want to do it in C#. I'm guessing Brandon would say yes. We could do it in PowerShell. And, but from within here, it's like a little mini tutorial walkthrough, and you just go through and you answer all the questions, or not answer the questions, but you go through each of the steps, do the exercise that it says to do, and then it checks to make sure you've actually completed the task before you move on to the next one.
Oh, just let you cheat?
No, you can't just write an Azure function, Brandon, to go through here and hit click on all the buttons and rack up your points. You actually have to do the exercises, which I think is great, because honestly, we all know, you have to do to learn. You can't just consume information from a book or from a live stream, podcast. All that kind of stuff will inspire you, give you information, but you got to actually sit down and do it. Yeah, and I would say you actually have to screw up and learn what not to do and make some mistakes before actual true learning takes place. I think if you just always nail it and you never figure out the things not to do, it's not quite the full picture of learning that we're looking for.
Yeah.
So
I wanted to show, just because you reminded me of, this video, so Microsoft hosted a conference recently called Start Dev Change.
Yeah.
And there was a really cool talk by PJ Metz called Confusion is the Sweat of Learning. And it's almost to a T exactly what you're just saying, Jason, that, yeah, as you're learning new things, you're going to fail.
Mm-hmm.
And you're going to be confused and things aren't going to make sense at first. But that's just part of the process. We can't let that.
Absolutely. Don't be afraid to, make mistakes.
So highly recommend it. PJ is actually a high school English teacher who's teaching himself or learning to code right now, teaching himself. And so he's kind of going through this confusion, and he wanted to kind of share his experiences. So
I love it. Yeah, I'll add that link into the show notes. And I think this is, in the chat here, we got one of our viewers saying that they stream and they call the stream Code by Mistakes for that very reason.
I love it.
And I feel like, that's kind of what we do here a little bit. It's kind of what we do on really any live stream that I've been on is it's not like we're improvising completely, but when something goes wrong, that's just part of it. We're not going to sugarcoat it and try to pretend like things always go well. And when you go online and stream like this and try to solve things in real time, and then you finally get to see or show other people that, every demo doesn't work perfectly. Everything isn't always set up right. It's not easy necessarily. So I think it's
roll with the punches.
Yeah. So, and that guy must have some good shirts, Hawaiian t-shirts or Hawaiian shirts that he wears all the time.
Actually, I just noticed that. That is, let's zoom in. That looks like a Nightmare Before Christmas.
Yeah, I like that.
And so actually that makes sense because this conference, well, here's the timestamp. I was gonna say it was mid-October. So
okay, that makes sense.
PJ is leaning into the Halloween aesthetic.
Right, all right. Cool. Well, let's pop back over to the Learn module. I just want to see if there's anything else to point to before we start wrapping things up here. Exactly. This test timer part that's what reminded me of what we were doing last time. Is we were setting up these, like I mentioned, these cron job looking things. So anybody who wants to go in and learn more about these timers, or not timers, all these different triggers, HTTPS is the one I almost always use because it's usually like what we were talking about at the beginning of the show. It's my thing is a service. It's a microservice to other things. And so I'm going to send probably a JSON package over to that to trigger it as an HTTPS or an HTTP trigger and move forward. So I loved the Learn module, the getting started Learn module, but this seems to be sort of like the next evolution. And a lot of the stuff that we've been talking about is great. You've written your code, but now how do you get things to fire?
Right. Because again, the thing you always have to keep in mind is when we're talking serverless, that means that we're not consuming resources unless we're triggered, unless our code is awoken. Woken up. And so, all right, we always write woke code, but sometimes it has to be woken up. And so, like what's going to be our trigger? And I agree with you, Jason. I think the most common one is HTTP trigger because it's a get, post, delete, API.
And the question came up in chat is this could this be a webhook? And that's pretty much like, I think the very first way I ever triggered a function was with a webhook. So believe so.
Nice.
Yeah. So excellent. Well, this has been great. We've just got a few seconds left here to wrap up and say goodbye. Thank you to everybody who's joined us in chat, both over on Twitch, over in Learn TV. Hope you participated in the polls and had a good time today. Thank you, Brandon, for joining me once again, carrying on this conversation of serverless. We will have to look at the calendar and figure out where part 4 will fit in, but we will make that happen. And thank you to everybody kind of paying attention in chat, helping us moderate today as well. And enjoy the rest of your week. We'll see you next week again on All Around Azure. See you then. Bye.